According to the National Electrical Code, it is not permitted to replace the wood above insulation with screws or any other material for occupant step space around recessed lights. There are several reasons for this. Firstly, fire hazard. Insulation is designed to prevent the spread of fire. Removing or cutting it creates a potential pathway for flames to travel. Secondly, electrical safety. The presence of conductive materials, such as screws, near electrical wires can increase the risk of electrical shock or fire. Thirdly, building code violations. Most building codes require that insulation be installed around recessed lights, without any gaps or obstructions. Here are some acceptable solutions. Firstly, use insulation contact-rated fixtures. Install recessed lights that are specifically designed for insulation contact-rated. These fixtures have a thermal cutoff sensor that automatically shuts off the light if the temperature around the fixture becomes too high. Secondly, create an air gap. If you must access the recessed light from the attic, create an air gap by removing a portion of the insulation directly above the fixture. This air gap will allow heat to dissipate without overheating the insulation. Thirdly, use a remote junction box. Install a remote junction box outside of the insulated area. Run wires from the recessed light to the junction box, and then install a cover or trim plate to access the wires. In your case, you must cut a hole in the attic floor for access to the two recessed lights. You may not replace the wood above the insulation with screws. You should use one of the acceptable solutions described above to ensure electrical safety and fire prevention. When working with electrical components, it's crucial to prioritize safety and adhere to the National Electrical Code, or NEC, guidelines. Improper installation or modifications can lead to fire hazards, electrical shocks, and building code violations. Let's delve deeper into the reasons why replacing wood above insulation with screws near recessed lights is not allowed, and explore the recommended solutions. Insulation plays a vital role in preventing the spread of fire within a building. It acts as a barrier, slowing down the transfer of heat and flames. When you remove or cut insulation to create space for accessing recessed lights, you compromise this fire barrier. This creates a potential pathway for flames to travel more quickly, increasing the risk of a fire spreading rapidly throughout the structure. Electrical safety is another significant concern. Introducing conductive materials, such as metal screws, in close proximity to electrical wiring increases the risk of electrical shock or fire. If the screws come into contact with live wires, they can become energized, posing a serious threat to anyone who touches them. Additionally, arcing can occur, potentially igniting nearby combustible materials. Building codes are in place to ensure the safety and integrity of structures. Most building codes explicitly require insulation to be installed around recessed lights without any gaps or obstructions. This requirement is intended to minimize the risk of fire and ensure proper energy efficiency. Violating these codes can result in fines, penalties, and the need for costly repairs. Fortunately, there are several acceptable solutions you can implement to address the need for accessing and working with recessed lights while maintaining safety and code compliance. One of the most straightforward solutions is to use insulation contact-rated, or IC-rated, fixtures. These recessed lights are specifically designed to be in direct contact with insulation without posing a fire hazard. They incorporate a thermal cutoff sensor that automatically shuts off the light if the temperature around the fixture exceeds a safe level. This feature prevents overheating and reduces the risk of fire. If you need to access the recessed light from the attic, creating an air gap is another viable option. This involves removing a portion of the insulation directly above the fixture. The resulting air gap allows heat to dissipate freely, preventing the insulation from overheating. It's essential to ensure that the air gap is large enough to provide adequate ventilation, but not so large that it compromises the overall insulation effectiveness. Installing a remote junction box is a third acceptable solution. With this approach, you locate the junction box, which houses the electrical connections, outside of the insulated area. You then run wires from the recessed light to the junction box. This arrangement keeps the electrical connections away from the insulation, reducing the risk of overheating and fire. To access the wires, you can install a cover or trim plate over the junction box. In your specific situation, where you need to cut a hole in the attic floor to access the recessed lights, it's crucial to avoid replacing the wood above the insulation with screws. Instead, focus on implementing one of the acceptable solutions outlined above to ensure electrical safety and prevent fire hazards. Remember to always consult with a qualified electrician or building inspector to ensure that your installation meets all applicable codes and regulations. Proper planning and adherence to safety guidelines are essential for protecting your home and family from potential hazards associated with recessed lighting. When dealing with electrical installations, it's paramount to understand and follow the National Electrical Code, or NEC. This comprehensive set of standards provides guidelines for safe electrical practices. Failing to comply with the NEC can lead to serious consequences, including fire hazards, electrical shocks, and property damage. Let's examine some common electrical safety considerations related to recessed lighting. One of the primary concerns with recessed lights is the potential for overheating. Recessed fixtures can trap heat, especially when they are covered with insulation. Excessive heat can damage the fixture, melt insulation, and even ignite nearby combustible materials. To mitigate this risk, it's essential to use insulation contact-rated, or IC-rated, fixtures. These fixtures are designed to withstand higher temperatures and incorporate thermal protection mechanisms. Another critical factor is proper wiring. Incorrectly wired recessed lights can create a fire hazard or pose a risk of electrical shock. Ensure that all wiring connections are secure and properly insulated. Use the correct wire gauge for the circuit and follow the manufacturer's instructions for wiring the fixture. Grounding is another essential aspect of electrical safety. Recessed lights, like all electrical appliances, must be properly grounded to prevent electrical shock. Connect the grounding wire from the fixture to the grounding wire in the electrical box. This provides a path for straight electricity to flow safely to the ground, protecting you from harm. Insulation plays a crucial role in energy efficiency and fire safety. When installing recessed lights, it's vital to maintain proper insulation around the fixtures. Avoid compressing or obstructing the insulation, as this can reduce its effectiveness and create a fire hazard. Use insulation that is specifically designed for use around recessed lights. Clearance is another important consideration. Maintain adequate clearance between the recessed light and any nearby combustible materials, such as wood framing or ceiling joists. This clearance allows for proper ventilation and prevents the materials from overheating. Follow the manufacturer's instructions for recommended clearance distances. When working with electrical systems, it's always best to err on the side of caution. If you are not comfortable performing electrical work yourself, hire a qualified electrician. A licensed electrician has the knowledge and experience to ensure that the installation is done safely and correctly. Before starting any electrical work, always disconnect the power to the circuit at the breaker box. This prevents accidental electrical shock. Use a voltage tester to verify that the power is off before touching any wires. Regularly inspect your recessed lights for any signs of damage, such as cracks, frayed wires, or loose connections. If you find any problems, repair them immediately. Neglecting these issues can lead to serious safety hazards. By following these electrical safety guidelines, you can minimize the risks associated with recessed lighting and create a safer environment for yourself and your family. Remember to consult with a qualified electrician or building inspector if you have any questions or concerns. The National Electrical Code, or NEC, provides specific guidelines for installing recessed lighting safely and in compliance with regulations. These guidelines cover various aspects of the installation, including the type of fixtures to use, wiring methods, and insulation requirements. One of the key NEC requirements for recessed lighting is the use of insulation contact-rated, or IC-rated, fixtures in certain situations. IC-rated fixtures are designed to be safely installed in direct contact with insulation without posing a fire hazard. This is especially important in attics and other areas where insulation is prevalent. The NEC also specifies the types of wiring methods that are permitted for recessed lighting installations. Common wiring methods include non-metallic sheath cable, or NM cable, and flexible metal conduit, or FMC. The choice of wiring method depends on the specific application and local building codes. Insulation is another critical aspect of NEC compliance. The NEC requires that insulation be installed around recessed lights in a manner that does not create a fire hazard. This typically involves maintaining a specific clearance between the fixture and the insulation. The NEC also addresses the issue of recessed lighting in damp or wet locations. In these areas, the NEC requires the use of listed and labeled recessed lights that are specifically designed for wet locations. These fixtures are constructed to prevent water from entering the electrical components. The NEC also provides guidelines for the spacing and placement of recessed lights. These guidelines are intended to ensure adequate lighting levels and prevent glare. The NEC also addresses the issue of recessed lighting and suspended ceilings. In these installations, the NEC requires that the fixtures be securely supported by the ceiling grid. The NEC also covers the use of recessed lighting in hazardous locations. In these areas, the NEC requires the use of explosion-proof recessed lights that are specifically designed to prevent ignition of flammable gases or vapors. The NEC also provides guidelines for the use of recessed lighting in healthcare facilities. In these areas, the NEC requires that the fixtures be installed in accordance with specific healthcare requirements. The NEC also covers the use of recessed lighting in recreational vehicles. In these installations, the NEC requires that the fixtures be listed and labeled for use in recreational vehicles. The NEC is a complex and comprehensive set of standards, and it is essential to consult the NEC directly for specific requirements related to your recessed lighting installation. You may also need to consult with a qualified electrician or building inspector to ensure that your installation meets all applicable codes and regulations. Adhering to the NEC guidelines is crucial for ensuring the safety and legality of your recessed lighting installation. Remember that electrical codes can vary depending on your location, so it is always best to check with your local authorities to determine the specific requirements in your area. When working with electrical systems, safety should always be your top priority. By following the NEC and other applicable codes and regulations, you can minimize the risks associated with recessed lighting and create a safer environment for yourself and others.